Welcome back to The Explainer. I am so incredibly pumped you're joining us today. If you're the kind of person who just loves figuring out the hidden mechanics of the world, but, doesn't necessarily want to drown in a sea of complex math equations, well, you are exactly where you need to be. Today, we're taking a super high-energy look at statistical dynamics, specifically the principles of correlation and regression. Our main mission here is actually pretty simple, but it's a real game changer. We are going to completely demystify how data relationships actually work. We'll break these concepts down so clearly that you'll literally start seeing them operating everywhere in your day-to-day life. And yes, we're doing the whole shebang without getting bogged down in the heavy calculus. Let's get into it. So, how do variables interact? Look, this isn't just some dry academic question. It is the core problem we face every single day. We live in a world that is just an absolutely chaotic swirl of variables. Think about it for a second. Weather patterns, global stock prices, even just the amount of sleep you get versus how productive you are at work the next day. Literally everything we experience is a variable. But how do they actually connect to one another? We desperately need a structured, reliable way to make sense of those connections, rather than just kind of going with our gut feelings or throwing darts in the dark. Okay, let's dive into this with our first section, the meaning of correlation, where we're really just building the foundation. Now, what's really fascinating about this concept is just the sheer elegance of it. Correlation does something incredibly specific, yet absolutely powerful. It measures the strength and the direction of relationships between variables. That's really the core of it. Its primary job is simply to find the hidden patterns buried inside all that chaos. Think of it like a radar. It's constantly scanning and telling us, hey, when this one particular thing changes, does this other thing change too? And even more importantly, how strongly are they marching to the exact same beat? And to measure all this, mathematicians handed us this beautifully simple scale. It ranges entirely from a -1 to a +1. That's it. This strict numerical range is the ultimate boundary for measuring exactly how strongly variables relate and in what direction they're moving. It is incredibly intuitive. A perfect +1, well, that means they move perfectly together. When one goes up, the other goes up, exactly in tandem, kind of like the hours you spend studying and your resulting test scores. Now, a perfect -1 means they move in exact opposite directions. One rises, the other falls proportionately. Think of the miles you drive and the amount of gas left in your tank. And smack in the middle, at 0, that means there is absolutely no relationship whatsoever, just pure measurable clarity. Right, so now that our foundation is rock solid, we need to categorize and measure these relationships. That brings us to section 2, measuring the relationship, tools, and types. Because as you know, not all data relationships are identical, so we use 5 specific categories to classify them. First up is simple correlation, which keeps things super basic by just looking at 2 variables. Then there's multiple correlation, for when several variables are interacting all at once. Next is partial correlation. This one brilliantly helps us isolate specific variables while controlling for all the background noise. And finally, we classify them by their geometric shape. Linear correlation, where the relationship moves at a constant rate, and nonlinear correlation, where things curve or shift at different magnitudes. Bam! Those are your 5 distinct types, giving us a really robust toolkit for pretty much any data scenario. But how do we actually see these different types in action? Well, they're visualized through scatter diagrams. This is absolutely the crucial visual tool for studying these specific correlation types. By plotting individual data points directly onto a graph, literally scattering them across the page, we can instantly visualize the pattern. We can immediately see if those points form a tight angled line, maybe a loose cloud of noise, or a big sweeping curve. The scatter diagram brilliantly takes abstract, clunky numbers and transforms them into a tangible picture our brains can just instantly process. And this brilliantly illustrates the 2 key mathematical methods running behind the scenes to calculate these relationships. We've got Pearson's coefficient on one side and Spearman's rank correlation on the other. Now look, I know I promised we wouldn't be doing heavy math today, but it is absolutely essential to know that these 2 analytical powerhouses exist. They are the mathematical engines that take all that scattered data we just looked at and actually generate that precise defining number between -1 and +1. So this brings us to a massive pivot point in our analysis. Here is the big question. We understand the relationship now, but how do we predict the future? I mean, it's one thing to look backward at a scatter diagram and confidently say, okay, I see how these 2 things are connected. But it is an entirely different, much more powerful thing to leverage those proven connections for actual foresight. We've got to take what we've learned and evolve it. And that ultimate evolution of data analysis is what we're diving into next in section 3, the power of regression. The ultimate solution. Regression extends correlation by predicting one variable from another. Notice how naturally that flows. It absolutely does not replace correlation. Instead, regression is a direct logical extension of the exact concepts we literally just covered. Once correlation proves to us the strength and direction of a relationship, regression grabs the baton. It hands us the incredible analytical power to say, hey, because I know the exact value of variable A, I can confidently and mathematically predict the value of variable B. So let's see how this all comes together. Here is our final stage, Section 4, Forecasting the Future, Putting it into Practice. Let's move to our framework and see how this builds logically from our underlying principles. Step 1. Establish regression lines. We take that visual scatter diagram we talked about earlier, and we calculate the absolute best-fitting line right through the center of the data. Step 2. Create equations. That regression line isn't just a pretty drawing. It gets translated into a strict, workable mathematical formula. Step 3. Quantify average relationships. That new equation scientifically locks in exactly how much one variable changes, on average, whenever the other variable moves. And finally, Step 4. Allow forecasts. Armed with that fully quantified relationship, we can map out future outcomes with, honestly, striking confidence. So, the crucial point here is that allowing forecasts is the ultimate goal of everything we've discussed today. Forecasting is the absolutely powerful destination of this entire mathematical journey. We didn't just measure the data from a -1 to a +1 just for the fun of organizing numbers, right? We did it so we could systematically build those regression lines, write those definitive equations, and ultimately gain the incredible, almost superpower-like ability to forecast future events based on solid, proven relationships. As we wrap up this explainer, I want to leave you with one final, kind of provocative thought to ponder. What relationships currently exist in your own data, just waiting to be forecasted? Think about the environment you operate in right now. Your business metrics, your personal habits, your daily workflow. These interacting variables are all around you, constantly acting and reacting. Now that you understand the foundational principles of correlation and the true predictive power of regression, you have the exact conceptual tools you need to find those hidden patterns and anticipate what comes next. Thank you so much for hanging out with me today. Keep learning, keep looking for those brilliant connections, and I will see you next time.